Alrighty, so the next thing to do is to do sort of the reverse, where if you're given a formula, how you get a name out of it, how do you produce a name? Now, there's three kinds of ways that we can name compounds depending on the type: ionic, molecular, and acids. And we'll talk about each one, but let's do number one first, which is ionic. So when you're naming ionic compounds, we're going to use or any one of these three methods. We're going to use what's called a binary naming system. And a binary system has got two parts to it. Now, within that, there's three types of naming. And they're very similar, but a couple of little things that are different. So in the first type is when you're dealing with a metal with a nonmetal. The second type is a metal with a nonmetal, but the metal is special. And the third type is either type 1 or type 2, but when you have polyatomic ions, which we've talked about. So let's take the first one first, which is when you have a type 1 with a metal and a nonmetal. So the first thing that you do is you just name the metal. Just find it on the periodic table, name it. And for this type, it's only for metals that are in group 1, group 2, or they are silver, zinc, or aluminum. Okay. And again, following this stepwise process that we're doing. So you name the metal, and then you name the nonmetal, but you change the ending of the nonmetal to IDE. So let's try one. So LiF. Li is lithium. Is lithium in group 1, group 2, is it aluminum, zinc, or silver? And the answer is yes. It follows into group 1 on the periodic table. The next thing is that you have F. Fluorine turns into fluoride. You change the ending to IDE. And so, lithium, fluoride. That's it. That's all there is to it. So this only works when you have a metal that's in group 1, group 2, aluminum, zinc, or silver. Now, what happens when you don't have a metal that's in group 1, group 2, aluminum, zinc, or silver? That's the next type, type 2. So here what you do is that you name the metal, find it on the periodic table, name it, and then verify that it's not in group 1 or group 2 or aluminum, zinc, or silver. And if that's the case, if that is true, what you're going to do is you're going to use a Roman numeral in the way that I'm about to show you to show what the charge of the metal is. The metal, in other words, just one metal, the metal that's in it. And you're going to use a Roman numeral ranging from 1 through 10, and we're not going to go past 10. And you've probably seen most of these before, but these are ones if you've got to know these. And then what you do once you've done that is then you look at the nonmetal, you change the ending to IDE, and then you wrap it up. You do it. So let's try one. So Cr2O3. So when you look at Cr2O3, Cr, chromium, is not in group 1, it's not in group 2, it's not aluminum, zinc, or silver. So since that's the case, it has to have a Roman numeral, and we will figure out what that Roman numeral is in a moment. So that's the first thing. So we need a Roman numeral. Now to figure out the Roman numeral, here we go. How do you do it? It's a couple of ways. So remember that all ionic compounds have a charge of 0 when you have positive and negative together. So we can use a little algebra and say if the positive charge plus the negative charge equals 0, the formula says there's 2 chromiums. So here it is, 2 chromiums. This is 3 oxygens. There's 3 oxygens right here. Now, we don't know the charge of the chromium, which we need to figure out. But there's 3 oxygens, and each oxygen, based on what we talked about in the previous chapter, is -2. So when you do the algebra here and you solve for it, you have x is +3. Therefore, the charge of the chromium is +3. So we know its Roman numeral will be a 3. So the other way is to do the crisscross method. If you remember the crisscross method, you just reverse it. You go backwards. And when you do that, that makes that subscript on the oxygen become the positive charge of the chromium, which is Roman numeral 3. So it's +3. So Roman numeral 3 is what we're using. Chromium, then Roman numeral 3, and then oxide. So that's how you name the second type.